Alright, quick video to go over these examples for you guys. So we're looking at mixture problems, modeling with these rational equations we've been talking about. So the first one we're talking about work completion. You have two people doing a job. One person works faster than the other. You got to figure out how long it would take them to do it together, or vice versa, depending on what information you have. So in this case, it says Doug takes twice as long as Becky to complete a project. Together they can do it in 10 hours. How long would it take each of them if they had to do it by themselves? So basically we have one project is taking X number of hours. Okay, so this is kind of the basic setup for each of these. So we're going to say if Doug was doing it himself, it would be one project over Doug's amount of time. But we also have Becky, who's helping here. So we add the two of them together, and that means that one project is done in 10 hours. Okay, so this is kind of the setup that we're looking at here. So whenever you have something like this, you only want to have one variable in order to solve it. You can't solve an equation with two variables unless you have two equations. So we're going to use the fact that they said Doug is slow. He takes twice as long as Becky. So Doug's time is equal to double what Becky's time is. So I'm going to take that and plug it in here and make a new version of this. So then, like we talked about before, if you have fractions in an equation, get rid of the fractions. That's the easiest way to do it. So I'm going to multiply everything by all of these pieces of this fraction. So I have a 2, I have a b, and I have a 10. Okay, that's each of these pieces on here. A 2, a b, and a 10. So if I multiply every piece in there by that, I can wipe out the fractions altogether, and it makes it way easier. So I have 2b10 here, 2b10 here, and 2b10 here. So now let's cancel some stuff out. So here the 2 and the b will cancel, and I'm left with 10 times 1, which is 10. Here I have just a b that cancels, so I'm left with a 2 times a 10 times a 1, so that's 20. And then here I have a 10 that cancels, so I'm left with a 2 and a b. So then we can solve that. So this means that Becky, by herself, can do the job in 15 hours, where Doug, Slowpoke Doug, he takes double that time, so his would be 30 hours. Okay, so that's the combined work problems. The other ones that we see a lot are these mixture problems. You have a solution, you got to have it a certain amount, certain percentage, so on. So here we have how many liters of a 10% acid solution should be mixed with 30 liters of a 50% acid solution to make it so that it's 20%. I don't know if you've ever done problems like this in chemistry or anything like that. But what we're trying to find is how much of this 10% are we adding. So 10% times, we don't know. That's what we're going to find. This is how much we're adding in of that. Then we know that the 50% solution, we have 30 liters of that. And when this is done, we want a 20% solution. But then in here, what we're taking is the percentage times the amount that you have there. So I have 10% at X liters. I have 50% at 30 liters. I want 20%, and this would become X plus 30, because we had the 30 that was already there, and we're adding in X amount. And now you're basically just solving this. So 0.1x plus 15 equals 0.2x plus 6. That's a 6. and then bring everything to one side or the other. So if I subtract 0.1x and I subtract 6, this is 9 equals 0.1x. So x equals 90. So that means we would add 90 liters of the 10% solution in order to meet that requirement.